So guys, welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we are going to solve these 10 JAMB repeated practice questions for your chemistry. So in short, to stay till the end of this video. If at any point you feel you want to answer the question before we provide the answer hereafter, you can always pause the video and try out the question even before we provide the answer hereafter. So guys, here, without wasting much of our time, we are going to start with the first question here. Question number 1. It says, the solubility of potassium hydrogen triisocarbonate 4 is 0.42 moles per dm cube at 25 degrees. What is the mass of potassium hydrogen triisocarbonate 4 in 200 cm cube of a saturated solution of the salt at 25 degrees Celsius? So we have here that potassium hydrogen triisocarbonate 4 is given as 100 gram per mole. That's the mass concentration. So guys, we are going to simply zoom into our workspace here and try to solve this out. So we're going to be needing our calculator, so let's just bring up our calculator here. So let's start. So first of all, we are given the mass concentration. So potassium hydrogen triisocarbonate 4 is given as 100 gram per mole. That's the mass concentration given to us here. And then we are also given the molar concentration here, and that's 0.42 moles per dm cube. So guys, remember, what we are now looking for is the grams. So guys, but then remember, the question says the solubility of potassium hydrogen triisocarbonate 4 is 0.42 moles per dm cube at 25 degrees. What is the mass of potassium hydrogen triisocarbonate 4 in 200 cm cube? So now remember that this concentration we have here as the molar concentration is the molar concentration in 1000 cm cube or in 1 dm cube of the solution. So this is the concentration in 1 dm cube of the solution. That's 0.42 moles per dm cube. But guys, we are looking for, we have to get the concentration in 200 cm cube of the solution before we're able to solve with this. So guys, if 1 dm cube of the solution is 0.42 mole, gives us 0.42 moles, so 200 cm cube of the solution will give us what? So guys, we don't know, we are going to cross this out and multiply. So 200 cm cube is going to multiply this. So having established this, we know that 200 cm cube is the same as 200 over 1000. 200 divided by 1000, it will be 0.2. So guys, we're going to cross this now. So this is actually 0.2 times 0.42. So we have 0.2 times 0.42 over 1 dm cube here. So guys, let's multiply this out. 0.2 times 0.42, that will give us 0.084 moles of this. So guys, now that we have gotten the number of moles here to be 0.084 moles, so we are going to wipe this entirely, and then we have 0.084 moles given here now. So guys, since we have the number of moles now, we can now go ahead and get the mass in grams, since we have been given the mass concentration. So guys, you know that the mass concentration is gram per mole, and then the number of moles here is mole. So if we simply multiply these out, the moles will cancel out, and then we'll have the gram. So guys, that's how we are going to do this. We are going to multiply the mass concentration given to us, and that's 100 gram per mole. Then we are going to multiply it by the number of moles we got from this calculation, and that's 0.084 moles. So guys, when we multiply this out, let's see what we'll have. 100 times 0.084, and that's 8.4 grams. So guys, that's the answer to this question, and here guys, that's the option A. So let's quickly wipe this, and let's go ahead and check out the next question, guys. The next question here is question number 2, guys, and the question says, which type of salt is found in antacid medications and is used to relieve heartburn and indigestion? A, aluminum chloride. B, magnesium chloride. C, sodium chloride. D, calcium chloride. So guys, the answer to this question is option B, and that's magnesium chloride. So magnesium chloride is used in antacid medication to relieve heartburn and indigestion. So let's look at the next question, question number 3, and that's, we have a diagram here, guys. The question says, use the diagram above to answer this question. The caustic soda solution in the conical flask serves to A, remove carbon dioxide from ethane. B, dry ethane gas. C, remove sulfur dioxide from ethane. And D, remove carbon monoxide from ethane. So guys, the answer to this question is option A. So caustic soda solution is actually used to absorb any carbon dioxide or sulfur dioxide that is produced during the reaction. So guys, that's the answer to this question, and that's option A. So let's look at the next question, question number 4. It says, proteins in acid solution undergo A, substitution. B, polymerization. C, fermentation. D, hydrolysis. So guys, the answer to this question is option D, and that's hydrolysis. Actually, hydrolysis occurs when proteins are placed in acid solutions. So let's look at the next question, question number 5. The salt that reacts with dilute hydrochloric acid to produce a pungent smelling gas, which decolorizes acidified purple potassium tetraoxomanganate 6 solution, is A, sodium trioxosulfate 4. B, sodium sulfide. C, sodium tetroxosulfate 6. D. Sodium triisocarbonate 4. So guys, the answer to this question is option A, and that's sodium triisosulfate 6. So let's consider the next question, and that's question number 6. It says, the salt formed from a strong acid and strong base is A. Acidic, B. Complex, C. Neutral, D. Basic. So guys, the answer to this question is option C, and that's neutral. A salt that is formed from a strong acid and strong base is a neutral salt. So let's consider the next question. Question number 7. It says, an insoluble salt can be prepared by A. the action of dilute acid on an insoluble base, B. the reaction of triisocarbonate 4 with an acid, C. double decomposition, D. the reaction of metals with an acid. So guys, the answer to this question is option C, and that's double decomposition. So let's consider the next question. Question number 8. It says, hydration of ions solution is associated with A. conduction of heat, B. liberation of heat, C. absorption of heat, D. reduction of heat. So guys, the answer to this question here is option B, and that's liberation of heat. Hydration of ions in solution is actually associated with liberation of heat. So in this question, you have to understand that in hydration, heat is actually liberated. So that's it for that question. So let's consider the next question. Question number 9. It says, the type of salt that ionize to produce 3 different ions in solution is A. double salt, B. acidic salt, C. complex salt, D. basic salt. So guys, the answer to this question is option A, and that's double salt. Double salt can ionize to produce 3 different ions in solution. So let's consider the next and the last question, and that's question number 10. It says, which of these compounds is a normal salt? A. sodium hydrogen sulfide, B. sodium hydrogen triisocarbonate 4, C. sodium hydrogen tetraisosulfate 6, and D. sodium triisocarbonate 4. So guys, the answer to this question is option D, and that's sodium triisocarbonate 4. So sodium triisocarbonate 4 is the only normal salt within these options here given to us here. So it does not contain a hydrogen ion. It is formed by the complete replacement of the hydrogen ions that are present in the acidic compound that it was formed from. So in this case, guys, sodium triisocarbonate 4 is the answer to this question. So guys, this is where we end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any question regarding this video, please drop your question on the comment section below, and we'll ensure to give you a response as soon as possible. So guys, we also encourage you to join this channel membership in order to get premium information on JAMB updates, as well other things you might be needing in order to prepare for your JAMB. So guys, see you in the next video, and thank you for watching this video.